All right, so if we have a data set and we want to try to draw a line that best fits the data set, one way is just eyeball it and draw a line through it as best you can. So you see on this screen here is the data set for the crickets, the cricket chirps, and I have 5 different lines going through it. The problem with just kind of eyeballing it like this, as you can see here, is that it's kind of subjective and not exactly scientific. Really what we want is we want easily reproducible results. That is, whatever method I use can be used by anyone else and get the same results. So which line would be best for this kind of situation? Well, let's pause for a second and just kind of remind ourselves in terms of linear equations that if you've had past algebra classes, you probably have seen the form of y is equal to mx plus b. As statistics students, we're going to kind of reverse that, and hopefully it'll make sense with the last couple lessons for this quarter. But we'll use the form kind of b plus mx. Or more specifically, we'll use b naught b0 plus b1x. Where that b naught, or otherwise b0, that is the point estimate for the y-intercept, and b1 is the point estimate for the slope. And just remember, those point estimates is the value from our sample that is used to estimate the true value. So we're going to create samples, and based on our samples, we're going to find the point estimate for the intercept and point estimate for slope, and that will be our equation. Now, we need to distinguish between the actual y values of our data points versus the predicted data points from our line. So the way we do that is when we're talking about a line, we'll put a little hat over the y value. So given a slope and intercept, we produce what is called the fitted line. That is, y with a little hat over it is equal to b naught plus b1x. That little hat is used to signify that this is a prediction, though it is often missing when we use words instead of x and y.